Zolu learned the TV business in the fast lane. In less than a decade, he transformed a company on its knees into Europe's largest TV manufacturer. A TV is essentially a box that uses a light source, a circuit board, and a display panel to translate broadcast signals into moving images. But the TVs they make are constantly changing. Television technology evolves as quickly as computers, becoming brighter, sharper, and thinner. And now the TV and computer are fusing into one. It's called a smart TV. It lets users surf online, and it links up with tablets. For this factory, it takes an army of 800 researchers and developers to keep up with these technological trends. Making televisions takes three main components. The LCD panel, which displays the images themselves. The motherboard, which processes the broadcast signal and controls the TV's functions. And the frame, which is made inside gigantic molding machines. Each TV goes through meticulous testing before it gets assembled and packaged on the production floor. For the factory to easily adapt to the constantly changing marketplace, it needs an extremely flexible system, and being fully automated isn't going to cut it. That's why this mega factory depends so heavily on the human touch. The mega factory sprawls across 1 million square meters in the city of Manisa in western Turkey. At over 1 kilometer wide, Vestel city ranks as one of the largest industrial complexes in the world. The behemoth is a bustling hub with 7 core buildings. Headquarters, where the circuit and power boards are built for every device. 2 refrigeration factories, with ample floor space to fit 19 Titanics. Washing machines and dishwashers, which churn out enough machines to stretch from Istanbul to Brussels. Digital, where TV panels are made. And electronics, where the TVs are assembled and packaged.
I took a sheet of A4 paper and I said, I'm going to put a factory here, a factory there, there's going to be green spaces, and I took the A4 and gave it to the architect and I said, make it like this. It's 1,000 meters from here to here. And from here to here is another 1,000 meters. And this is the container area.
Zolu's baby became a giant. One of the biggest factory complexes on Earth, Vestel. Washing machine factory at Vestel City. The next generation of machines, the combined washer-dryer, is set for mass production. The combined washer-dryer is a first for this factory. But engineers have been working for years to come up with a machine that can function equally well in both modes. For the washing machine part to work, it needs a steel drum, where the clothes are washed and spun. An outer plastic drum, which holds the steel drum in a watertight tub. An electric motor that turns the steel drum to slosh the clothes about. And the weight stabilizer, which is basically a block of cement to hold the machine in place while it spins. The sliced metal makes the outer frame. And the most crucial component, the rotating drum. The drum seams are welded together inside what looks like a giant press. This is the single most crucial step of making a washing machine. It needs a drum too, but the washing machine one will work. Add an air heater, a fan that blows heated air into the drum, and a condenser that turns the water vapor back into drainable liquid. Once the washing machine has done its job, the dryer kicks into gear. Air from the drum is passed through a heater, raising its temperature to 130 degrees. This heated air is then blown into the spinning drum. As the dry hot air mixes with the wet clothes, the air becomes saturated with water vapour. A hose at the back of the machine sucks out the humid air into the condenser, where the air is cooled to convert the water vapour back into liquid. The liquid is drained away and the cool air sent back to the heater to start the process all over again. Getting these polar opposite systems to fit into one machine is an engineering conundrum.
Here, there can be problems that disrupt the airflow. We can see these in our analysis. What are the disruptions in this flow? It could be pressure drops and twists or unwanted divisions of the airstream.
To solve the space problem, engineers looked at ways to reduce the size of each component. First on the chopping board, the concrete block. Engineers designed a computerized inner ear that can detect when bunched-up laundry throws the machine off balance. The internal computer then changes the spin direction to balance out the load. This means they need less physical weight to prevent the machine from walking. They managed to shave 5 kilos off the washing machine, creating just enough space to fit the dryer. By solving the problems of space and airflow, the design team has created the fastest machine of its kind. It's capable of washing and drying a small load in only 35 minutes.